All right, welcome back. So next thing we're going to do is section 6.1. And this section is integration by parts. Okay. Integration by parts is basically the integral version of the product rule. Okay, and there is no integral version of the quotient rule, by the way. This is just integral version of the product rule. Okay, so let's start with the product rule. Okay, so the product rule says that if you take the derivative of u of x times v of x, that's going to be, let's write it this way. Oh, no, let's not. Let's write it this way. Du dx times v of x plus u of x times dv dx. Okay? So what we're going to do when we're doing our product, when we're doing our integration by parts, is we're going to assume our integral is of the form u of x, I'm going to write it here, v prime of x dx. Let's put some endpoints on here. Okay. Now, this is this thing, right? That's basically that thing. So we're going to say that equals to, okay, the integral from a to b, the derivative of u of x, v of x, dx, minus the integral from a to b, v of x, that's this thing, times du dx. dx. Let me write that u a little better. Okay, so now this thing just integrates straightforward. That's going to be u of x, v of x at a and b minus the integral from a to b, v of x, and let me write this as u prime of x dx. Okay? And the idea is this. Let me make sure this is, why did that in blue? Okay, the hope is that this integral should be easier to evaluate than this integral. Okay? Okay, so normally what you do, or when you see this sort of thing, is you normally start with what's called u and dv. Okay? So this is u, this is like a dv. Okay? This is uv. And this is v du. So the way that you normally see the integration by parts formula is the integral from a to b, u dv equals u times v evaluated at a and b minus the integral from a to b v du. Okay? Let's do a problem. Okay? So the first problem is actually it's not super crazy. We're going to take the integral of natural log of x. No, let's do it indefinite. Okay, so now what's nice about this is that this enables us to take the integral of natural log of x. I don't know what function has a derivative of natural log of x, at least not yet, but I will in a second. So what I'm going to do, I'm going to actually fit this into my thing. I do know the derivative of natural log of x, right? I know that. So that's really going to help me out. That means that natural log of x should be my u, because over here I'm looking for something I know the derivative of. Okay, so let u equal natural log of x. Now what's my dv? My dv here well, I'm going to actually let dv equal dx. That's one of the reasons why we use this language. Okay, so now du is 1 over x dx. We're going to keep that dx there. It's very common to do. Okay, and we need to do that. And then v, well, the antiderivative of 1 is just x. And we don't need the plus c here. Okay, we'll add the plus c on the end. Okay? So, now what does this become? So this is u dv. Okay, so the integral of u dv equals uv minus the integral of v du. Okay, that's our thing here. And then we're just going to match up. So v is x, natural log of x. So that's uv, I've got it mixed up there, minus the integral v du but x divided by x is just 1. So this is going to be x natural log of x minus the integral of dx x natural log of x minus x plus a c. Oh, that's pretty cool. Okay, and you should take the derivative of this and check that it does in fact give you natural log of x. Okay, all right. Let's take a break. We'll go to the next video now in a second.